Welcome to pages 13 through 18 of your integer word problem packet. On this page, we're going to be looking at a story problem that has 4 parts. We have to answer part A, part B, part C, and part D, all based on the information given above. Let's take a closer look at problem number 1, part A. Let's read together. Devonte used a number line to add, starting at 0, so we have 1 point starting at home base. He counts to 8. Next, he counts until he stops at the number -3. That's our final spot or our answer. Model the addition on the number line below. So together, cut the question along with me, take notes, and let's model the problem on the number line. Starting at 0, our single point or single chip starts here. And then we move, using a vector, 8 to the right. That's a gain of 8 or positive 8. Now our chip lies at positive 8. And we're going to turn around and move to the left with our vector and arrive at a final answer of -3. Circle that final answer. So the second vector that we drew must be worth a negative, let's think for a moment, or you can count, 11. So if we had to write a sentence for this particular addition problem, we would write, please copy this down, 8 plus a decrease of 11, or -11, equals a final result of -3. Please make sure you have your vectors properly drawn, and each vector should be labeled +8, -11, and of course we circle our final answer, -3. Now that we have our problem modeled on the number line, let's look at part B. Part B states, which sentence represents the addition problem modeled on the number line? So we're looking for a sentence, which, by the way, we already put down right here. So let's take a look. Well, it can't be A because we certainly didn't arrive at 11, so cross A off. It can't be D because our final answer wasn't 3. Cross D off. So, as we look at C and B, clearly it's choice C. 8 plus a decrease of 11, because it's negative, it's a decrease, equals a -3. Now let's take a look at C and D. In letter C, it states, which real-world story problem represents the addition problem modeled on the number line? So remember, this is the addition problem they're referring to. We have 8, and there's a decrease of 11 resulting in a -3. Well, is it letter A? 8 degrees increased by 11? No. Cross that one off. Is it B? 8 degrees decreased by 11 is -3. That seems to be quite good. If we look at C and D, you can see that the result here they're saying is 5, which is incorrect. And the same is true here. This is an incorrect result of 11, so get rid of that. Clearly, it's 8 degrees decreased by 11. Because that 11 is negative, it's a decrease. And finally, part D. Find the distance. When we say distance, instead of one endpoint or chip being shifted around the number line, basically we have 2 endpoints and we're finding the distance between the 2 endpoints. And we also know we're measuring a distance. Distance is never negative. So as we look at the choices, we see that choice C is negative 5 units. We can get rid of that. And choice D is negative 11. We can get rid of that. But nevertheless, let's sketch a number line, putting 0 in the middle, negative 3 below, and positive 8 above. These 2 endpoints are on different sides of 0. So we're going to take the 2 segments of line and add them up. So we would write the absolute distance to negative 3 plus the absolute distance to positive 8. Well, 3 units plus 8 units, that's 11 units in length. Clearly, choice A. Now let's take a look at another page. Take a moment now and turn to page 17. Page 17. And let's take a look at the problem given on that page. Again, this problem has 4 parts. Part A, Part B, Part C, and Part D. Let's begin with the story and work on Part A. Please make sure you're taking notes and following along with me. Debbie used the number line to add. Starting at 0, we put our 1 chip at 0. She counts to negative 10. So that's a loss of 10. Next, she counts until she stops at the number 2 on the number line. Model the addition on the number line. So we start here at 0, which is home base. Draw a solid dot at 0. We experience a loss of 10. So draw a vector and label that vector negative 10. Now that the chip has been pushed 10 units to the left, we have to take and draw a second vector, pushing that chip so that it arrives at a positive 2, because that's the answer to our addition problem, which means that vector must be worth a gain or an increase of 12. So here's the sentence we should write for this particular addition problem. A negative 10 plus an increase of 12 equals a positive 2. Let's take a look at letter B. Which sentence represents the addition problem modeled on the number line? Well, we've written it right here, so let's find the sentence. Clearly, as we look at our choices, we see that letter D is the correct sentence. Now let's move on to C and D. As we look at the sentence we just circled, we can see it's a negative 10 increased by 12 with a final answer of positive 2. So let's take a look at letter C, keeping this sentence in mind. Which real-world story problem represents the addition problem modeled on the number line? Well, we know it has to start with a negative 10, and all of our choices do. But we see it's been, since the 12 is positive, increased by 12, not decreased. So we can get rid of choice B and choice C. So is it negative 10 increased by 12 is a negative 2? Or is it negative 10 increased by 12 is a positive 2? It is choice D. And finally, let's look at part D. Part D is looking for a distance. It states, find the distance. Remember, when it comes to distance, it's 2 endpoints, and it will always be a positive length. Find the distance between negative 10 and negative 2. Well, let's look at our choices for a moment. And you can see that C and D are both negative answers. We know a distance or a length would never be negative, so you can cross those two off. But as with any multiple choice problem, you should think through your work and draw a picture and come up with an answer on your own first. So here's 0 on the number line. Here's negative 2, that's one endpoint. And here's negative 10, that's another endpoint. And connect the two endpoints, we want to calculate this distance. Well, they're on the same side of 0, so we know this overall distance is 10, but we have to subtract the 2 missing units here. We would write, and please take down these notes, the absolute distance to negative 10, take away the absolute distance to negative 2 equals, you're taking away the missing piece that's not shaded in. 10 take away 2 equals 8 units in length. So your answer is letter A. This concludes the video for page 17.